this session, DDoS Mitigation Support, Use and Lessons Learned. And we have a panel of professionals here who will lead the session, and I will let them introduce themselves. We have about an hour for the session. We'll end at about 11:50 and open it up for questions. Thank you.
Thank you. All right, well, welcome everybody. Thank you to this particular session on DDoS. As some of you know, we had a pilot going on with the K-12 group for the last year or so, and we learned quite a bit. So we're going to try to share what we've learned. Oh, sorry. Display right here. Try it next time.
How's that going to come up with a full layout?
All right. Yeah, we're going to share what we learned throughout the pilot and give you quite a bit of information. So we're going to try to get through some of the material. There's a lot of information on the slides that we're going to be showing, and hopefully it will be useful to anyone looking into this type of service down the road. We're going to be going over introductions here in a second, talk about the background and goals of the activity in general, talk about the options being selected, solution and setup of the environment, what happens during mitigation, a lot of lessons learned again, and we got quite a bit of feedback from the K-12 participants. We'll close out with some Q&A. So on the group we have here Wong from K-12, the executive sponsor of the pilot and activity, David Dustin from SBCSS, Dale and Don from Poway, Sana Bellamine, chief engineer of the architect of the solution that we employed, Michael Gong, a lead from the operations team that actually had to support and take calls and do the analytics during the activity, and myself as a security analyst for CENIC involved in the activity. So Luis, if you could go over some of the backgrounds of what we were trying to accomplish.
Sure. Good morning, everyone. My name is Luis Wong. And, first of all, I want to thank CENIC for willing us to work with K-12 on this pilot. Some of our K-12 folks, we're not the easiest segment to work with. But anecdotally over the years, we have heard a lot about DDoS and our schools being affected by these types of attacks. And as you may or may not know, some of our schools, have robust capacity, not as robust as some of our other segments. But nevertheless, our issues are around technical skills to deal with these things, these types of issues. And so we really needed to have a further understanding of what is actually happening in terms of DDoS, what is the frequency and magnitude, what are the issues that we're dealing with in terms of time of recovery, what are the types of applications that are being impacted, and really have a better understanding about some of these techniques and tools that are out there to help mitigate some of these concerns. We've been talking to CENIC over the years about helping us implement a pilot system. We were able to secure some state funding to help with the pilot program, and really was looking at providing the CENIC NOC with some additional tools to help our K-12 folks deal with these types of issues. On the other end, I know that CENIC was also really interested in understanding how to implement some of these types of tools in a network that's so complex in terms of scale and hit points of peering and those sorts of things. So overall, I think we kind of brought into a win-win scenario. And, we coalesced about 18 counties that were willing to participate in the pilot, and a group that was really interested in helping us out. So this is how we got here. Some of the stars aligned in terms of funding, some of the support systems, CENIC being willing and able to put some of their own resources in terms of staffing and engineering and a lot of the things that need to happen behind the scenes for something like this to get off the ground. So really appreciative and excited to share with you some of our results.
Yeah, and I welcome Sana. She's going to come up and talk about the actual environment.
Hi everybody. So we're here to tell our story. I think this is becoming a theme for the conference. We talked about this project about a year ago, and a year later it's actually implemented and was put into production. So I'll get into some of the specifics here of the engineering solution. Before getting into details, as we were discussing this project about a year ago, we had to decide between proceeding with an on-net solution or an off-net solution. In both cases, though, we were interested in in DDoS detection and DDoS mitigation. So on the left-hand side here is how the topology would have looked like if we had gone with an on-net solution. With an on-net solution, the appliance or the device providing the scrubbing service would sit directly on the current backbone. So with an on-net solution, the traffic flow would have been potentially bad traffic would be coming from the internet, be delivered to the current backbone. The current backbone will scrub the traffic or clean it and then deliver it to the site. Our decision was not to proceed with an on-net solution because we did not have the scrubber. We didn't have the tools to support the scrubber, and we wouldn't have been able to meet the time frame for implementation. So for the DDoS pilot, we proceeded with an off-net solution. So that means we had to go and identify the DDoS provider, an off-net DDoS provider we want to proceed with. So we went through that phase. So we've identified a DDoS provider, and in our off-net solution, the traffic flow is as follows. So the traffic comes from the internet. It goes to the DDoS provider's network. So the scrubber sits on the DDoS provider's network. They clean the traffic. They send it to us via a clean path. So this is a clean path. The traffic comes to CarWAN and then eventually is delivered to the site. So this line here is to illustrate one of the challenges with an off-net solution. CENIC has a large number of peers, a large number, and a set of ISP providers. So if we want because we're proceeding on an off-net solution, if we wanted to mitigate traffic, then we had to implement policies that would redirect traffic, the bad traffic, to the DDoS provider when we wanted to initiate mitigation. So it was important to come up with a new set of policies where when we enter a mitigation phase, then traffic is not routed this way, but it's routed this way for the specific prefix being mitigated. So this is the topology we've implemented in a bit more details. So we evaluated multiple off-net providers, and at the end, the decision was to proceed with the provider that was providing ISP, one of the providers' ISP services that CENIC was using at the time. So this is the CENIC backbone. CENIC has already had a 100 gig link in LA to our ISP provider, which is also our DDoS provider. So this is our 100 gig link in LA to the ISP provider. This is our 100 link in Sunnyvale to the same ISP provider. So what we did is we reserved 5 gig over that 100 gig link that was already existing for the DDoS traffic. So we did this in LA. We also did this in Sunnyvale. So LA was the primary path for receiving clean traffic from the DDoS provider. And then Sunnyvale was the backup path for receiving clean traffic from the DDoS provider. So the traffic flow is as follows. So bad traffic would come from the internet. CENIC would have to implement routing policies so that in case of mitigation, all the bad traffic will go to the DDoS provider. The DDoS provider will redirect the traffic to their scrubbing environment. The scrubbing environment on the DDoS provider's network will clean the traffic and then deliver clean traffic to us back via that 5 gig clean path in LA. But if for some reason that physical link is down, that the clean traffic could also be delivered to us via the 5 gig in Sunnyvale. So once the clean traffic makes it to the CENIC backbone, then it will be delivered to the site. So the service we signed up for with the cloud provider also had an attack detection service. The attack detection was via exporting NetFlow data, and this attack detection service came at an additional cost, so we only implemented the attack detection for a subset of pilot sites. So the one important thing with the our solution is to provision the service. We did not have to provision new physical service because we reserved some amount of bandwidth on existing circuits that we already had to our ISP provider. So this is the list of pilot sites. We worked with 26 pilot sites. All these sites had DDoS mitigation, had the DDoS mitigation service, but only a subset of the sites had the DDoS detection service. And the main reason for that, as I mentioned, is because there was an additional cost for the DDoS detection service. So 26 pilot sites here, and I personally would like to thank everyone on the site for working with us as we were figuring a lot of things out during the pilot. So a little bit of details about the technical setup. So first, for the NetFlow for the attack detection service, we had to we worked with the DDoS provider to export flow data and give them a restricted SNMP access in support of the DDoS detection. For the mitigation part of the solution, we had to implement two sets of routing policies. So the first set of routing policies was on our core routers. These are the routers that are facing the internet. And the main purpose of those routing policies was when we needed to mitigate, we had to have all the rules in place for immediately rerouting the traffic to the DDoS provider. So those were the policies on our core routers. In addition, we implemented a set of policies on our customer terminating equipment, and the purpose of these policies was so that we could immediately tag a specific prefix for mitigation when we needed to mitigate that prefix. The routing policies were designed to be compliant with manners, so we were careful with maintaining the origin of the prefix when we implemented the solution. In parallel to that, so we could only provide the detection service to a subset of sites, again, because it came at an additional cost. So we initiated some internal efforts for providing the attack detection service via our own NetFlow tools. So with that, we were able to extend the attack detection service to more sites at no additional cost because they were provided by CENIC's own internal experimental tool at the time. We also use our own NetFlow tool to validate the efficiency of the DDoS provider's detection service. So after we finished the setup and prior to going to production with the service, we actually tested the whole solution by setting up attack vectors from outside our network. So the purpose of these attack vectors was to make sure the traffic redirection, all those routing policies we had implemented were working as expected, but also to make sure the DDoS provider was actually mitigating these attack vectors we were originating ourselves. We also spent some time basically improving, prior to going to production, improving our own attack detection tools and building processes around those tools, especially working a lot with the NOC to make sure they were able to interpret the data in our own internal tools. And now I'm handing this off to Mike, I think.
Yeah, so, hello. Yeah, so to give you a story about how this affected our operations group, as you can all imagine, when you implement something like this, it does require an amount of training, not only on the tools, but the processes itself. And so we did a fair amount of training for our operations engineers. And I would like to say it came in 3 phases. The first phase is we wanted to make sure all our documentation was created and updated, that contained all the new tools, the processes, as well as the new router configurations that were going to be applied to all the edge devices. The second phase came into, we had to make all the configuration changes to the edge devices. So each one of our engineers took turns to make those configurations, and that allowed them to get more familiar with the new routing policies that we had to apply. And then lastly, to further kind of reduce the mitigation time, we set up a DDoS lab at our facility so that we could run our engineers through an actual live DDoS scenario. So we had a tool that would simulate a DDoS attack from outside and then have our engineers go through and reroute traffic through the scrubber. So while all this was taking place, we met with K-12 HSN and we met with our associates to make sure that everyone was familiar with the new process and everybody was aligned. As all this was taking place and new associates started coming on board, we had to start thinking about a policy around how long we would keep traffic mitigated for through the scrubber. And so we came up with if we're mitigating less than 1 gig of traffic, we would keep it routed through the scrubber for 48 hours. And any traffic that was more than 1 gig, we would only keep it in there for 24 hours. And the main driver of this was because we only had a 5 gig limit of return clean traffic, we wanted to make sure that that was kept open and clean for any new attacks that may occur. And I would like to say that there was one instance where we were mitigating 3 sites and we did hit that 5 gig limit. And during that time, we were mitigating 3/24 subnets. And so we had to go back and we had to really analyze traffic further and reduce that down to just host-based addresses. And lastly, I just want to say that our policy was to make no routing changes unless we first had the associate's approval.
Great, and that was the CENIC side of the selection setup, engineering setup process. Now we're going to go into the COE and site participants, their experience with the setup, and go right into mitigation experiences from them. So starting with, SPCSS.
So from San Diego County Superintendent of Schools, we're essentially an ISP for about 28 to 29 school districts. 300,000 students use our ISP services at any given time. And so we host 3 CENIC node sites, or K-12 HSN node sites that are connected to the CENIC network. The setup was really easy for us. I think all Michael's hard work was paid off in the sense that all we had to do was clearly identify the Class Cs we issue to each of one of our school districts and tie them to the specific node sites that they're home to. We gave that information over to CENIC, and then they incorporated it into their routing rules. The more complex process for us was the workflow. We had to essentially identify how the workflow would set up once we received communication from CENIC engineers that we were under attack, or we received information from one of our districts that we were under attack. We set up a workflow where we would tie in all the stakeholders, the district stakeholder, district technical contact, the COE technical contact, and of course the CENIC contact assigned with the mitigation. There was a number of communication workflows in terms of emails that go out so people were notified, and then kind of timelines set aside from that. Other than that work, it was pretty straightforward, really painless. There weren't any configuration changes that we had to make on our equipment. I couldn't be more thankful for all CENIC's hard pre-work there.
So from Poway's perspective, we're a school district. We have 36,000 students. And our setup was a little more complicated because we did not have a Class C. So we had to go to our ISP, which is the San Diego County Office of Ed, and obtain a full Class C, and then re-architect our network to incorporate that Class C to get started. We also had some challenges when we were being DDoSed in a process. So in the beginning, we didn't really have one, and we ended up creating 3 roles. And so when we were under attack and we had identified that, our staff would take one of the 3 roles. One of the roles was to call CENIC. One of the roles was to change some things on our firewall. So one of the things that we did was we reduced our firewall to only seeing traffic from the United States or Mexico. And that was to try to prevent some of the botnets from other places around the world from infiltrating. But The third role was actually the communication. We were communicating out to our site technicians, our principals, people like that, so that they understood what was going on. And that's
And kind of to Don's point, we sort of, you guys hear me, right? We sort of crashed into this pilot. We started getting hit pretty heavily right when the pilot was starting. I reached out to our county office of ed in something of a panic. And while we were developing our internal processes and working with the county office of ed, we stumbled across the CENIC pilot. Probably not as organized of a build up to it, especially since we sort of had to last minute completely redo our public IP range. But once we were into the process, everything, I mean, like David said, everything was already set up. Once we identified our internal processes, we'd sort of built out our internal roles. Getting started and set up into the actual pilot itself was pretty straightforward.
So we'll go into some of your mitigation actual experiences and how some of that went after the setup process.
At the COE level, like I said, we were very happy with CENIC's prompt analysis or prompt detection. In fact, I would say 90% of the time that CENIC was the identifier of the attack rather than the districts. And I think that has to do with some of the attacks that were levied against a number of our districts. We were really fully, I guess in my head, because I had actually, prior to my role at the COE, I was a director at one of the node site districts and was experienced the side effects of an attack on another district. So we were on a shared node. That district was under heavy attack, and of course the node site that was hosting all of our services was impacted. So I was really concerned about the effect that DDoS would have, to our mission. And then later on, as I came up to the COE, I was able to work with Luis and the rest of the people at CENIC to help become part of that pilot. So I had some vision of what we were going to expect, and I thought it was going to all basically be bandwidth consumption style attacks. That actually wasn't the case. A number of our attacks were SYN flood style attacks where they didn't even register on the analysis, the bandwidth analysis tools that we use or the districts use. Many of them didn't necessarily know they were under attack right away. Those that were bandwidth consumption attacks never really hit the saturation point on most of these high capacity circuits, because most of our districts are 10 gig, not all, but most. And so they were seeing some increase in traffic, but their pipes held up and their services held up. So it was really interesting to see that CENIC would notice these attacks ahead of time and be able to mitigate them pretty quickly before there was any negative impact at the district. Like I said, when the districts did experience the attacks or negative effects and they did contact us, we were able to reach out to CENIC right away. They were able to confirm that there was an attack, maybe that they didn't see right away, but the districts were experiencing and leverage those mitigation strategies. I think the biggest delays were the communication delays from the COE, from us to the districts and vice versa. We deal with most of our school districts range between the 3,000 and 10,000 ADA. They don't have a lot of technical staff. They don't necessarily aren't always available. We did everything we could to make it available via phone, email, text. But those things are the ones that took time. It wasn't the actual technical implementation. It was just the communication strategy. So, kind of a lesson learned from, not lesson learned, but an idea in the future is possibly automated mitigation effects right away, as opposed to waiting for confirmation. All of that comes with risks. Again, it was a reactionary. It was we saw the data coming. Basically, saw data or indications of the attack, and we reacted. We only had probably one or two, maybe one failed mitigation attack, and it was kind of a tricky one. It was something we'll deal with in the lessons learned section.
Yeah, and we didn't have any attacks that were failed to be mitigated. We were targeted almost exclusively with TCP SYN flood attacks, which were a lot harder to identify on the outset. So often we didn't know that we were under attack until our external alarms went off and let us know that services were going down. And there was some internal processes again that we had to work up as far as alerting. And there was a little bit of stumbling when we first started reaching out to CENIC to let them know, hey, we're under attack, turn it down. We noticed that there was a little bit of, depending on who you got a hold of, sometimes it was a little more effective than others. But a lot of that too, like David said, was developing internal communications, right? We're under attack. What's under attack? How are we being attacked? Gathering that information and communicating it out as an organization was really what took the longest. By the time we got the information out to CENIC, it was minutes later, instant relief, and we're back up. And most of these attacks, I mean, like Don said, 36,000 students across all of our sites, it would take everything down. I mean, we would have a district in panic, and then the ability to make a phone call and bring everything back online was wonderful. And even when it was took a minute longer than we felt like it should have, it's a lot better than not having it there at all. So yeah, exactly. Yeah, we've been pricing this out. So.
Very good. And then we're going to go into the CENIC side of that mitigation support and Mike and his team's use of some of the internal tools.
Yeah, so this is the dashboard that our operations group uses to determine if a site's being attacked. A lot of work went on in the background to get the dashboard to look like this. Each one of the colors represents an associate. And this dashboard right here is just kind of a normal day without any attacks happening. This next one, as you see, the dashboard look changed dramatically. You can see there's two big humps right here, and that would signify that an actual attack is happening. And from here, we can drill down and see which associate is getting hit. This next dashboard is similar. We can drill down to the exact network that's being attacked. Wait, can you go back one?
Yeah.
So I just want to point out in this dashboard right here, if you look on the right-hand side in the middle, that's unique source networks. So right there, that would tell you that it's a distributed denial of service attack, because there's many sources going to perhaps a single destination. And then you go to the next one. This last dashboard, we can drill down even more, and we can determine the exact host that's being attacked and also what type of attack it is.
So that was the support side and the analytics that had to happen from the operations team during a mitigation activity. So like I said at the beginning, we learned quite a bit. There were some specific goals that were trying to be identified during the pilot phase. The first one of the bullet points that was on the original slide is the frequency and magnitude of the attacks on the K-12 community. And what we got is of the 26 participant sites, there was an average of 3.8 attacks throughout the pilot across the sites. Some of them didn't get attacked, some of them got attacked quite a bit, but this is the distributed average across the environment. The distributed time, 22 minutes, 22.2 minutes of attack, and the size, 1.7 gigabit of attack again, if you get everything together and distribute it against 26 sites. The other items here, we've got the specific attack protocols. UDP reflection, by far, you can see this one here, was the attack of choice from all the people there. And this is a combination of either DNS, LDAP, or NTP reflection type of attacks. And then the rest of them were that port 80 SYN flood, some combo of multiple UDP or TCP, and then some very specific ports that were attacked specifically. And then here's just the size, of the attacks, ranging a couple of large ones, mostly in the middle of 1 to 5 gigabit, and then the durations, wide range of durations. With these two clumped together, here would be between 15 minutes or less. One of the things that we learned, how to decrease the traffic, the off-net solution we found out was definitely the way to go. We did have some large attacks. One or two actually were in the 30 plus gigabit range. So if that had been an on-net scrubbing solution, that would have taken up a good third of the CalREN network just to receive and scrub that traffic. So keeping it off-net was definitely the way to decrease the volume of traffic within the environment. The effectiveness, very effective for the most part. Again, there was some examples of things that didn't get through. So the scrubbing part was really good. There's interactive ability with the scrubbing provider, where when a specific thing was getting through, we could talk to them and tune some of the scrubbing process to stop very quickly a specific thing and not leave it up to their analytics to figure out if it's DOS or not. So that's just, again, a communication thing that we learned. The mean time to restore. Again, like I said, most of the time the targets never even really felt a lot of the attacks because of the amount of bandwidth that we had. So it was only in some specific instances that there was some actual effect that where mitigation needed to be activated, or sometimes it didn't get activated just because of the communication process. But whenever we got detected and started that communication process, this decision making was available to implement, and with the operational team having the training already involved, the reaction time was usually pretty quick from that regard. So the complexities and challenges of scaling out this service, because of all the hard work that Sana had up front, the complexity portion of it was really addressed early on in the overall design. So the scaling as a complexity part wasn't that hard. The challenge was resources during actual onboarding in addition. So the design part, the engineering part was there. It was the actual resource, both the technical of having storage capacity and processing capacity, which needed to be scaled up potentially, or the human capacity of actually people working to make these things so that those dashboards that you saw look really pretty. There was a lot of effort behind that to make them look and work that good. In addition to just the visual part, there were some attempts successful attempts to get actual automated alerting internally within our environment as well, not just the outside part. And I think we're going to go into lessons learned. And this one was from the district and COE and participant side.
Yeah, so for the COE side, we certainly learned that the extra capacity the K-12 HSN has provided for most of our node sites is are really helpful. Also, districts obviously are making significant investments in extra capacity. I shouldn't say excess, extra capacity. And just the types of attacks that SBCSS experienced this round, we didn't see a lot of negative impacts due to those with the higher bandwidth style attacks. We did see negative impacts with some kind of port-specific or service-specific style attacks, particularly NTP reflection attacks caused some problems not only on the mitigation side, or not only on the district side, but some of the mitigation side. Although for the most part, we were effectively able to mitigate them. One of the real things that the takeaway from this pilot was we also learned a lot how we can help districts mitigate these things on their networks as well, especially for those non-bandwidth style attacks, the SIM flood style attacks. A number of the attacks could have been at least diminished in their negative effects by firewall configurations or some network engineering and getting some extra insight. As of now, we don't run flow on our node sites just because we don't have that capacity. We're looking into it. So we got some extra insight from CENIC by providing us that data. We were able to work with the various districts because we're service providers to those districts. So we want to work with their vendors. We want to work with their network engineers and see if they've got all the proper strategy or all the proper tools turned on that will help minimize the negative effects. And we did. We were able to learn a lot. And we now, as a department, can offer better services to our districts when, even if this pilot isn't able to be reborn, hopefully it will be, when they experience attacks, because we know that it's just a matter of time. We learned quite a bit about it, about the traffic kind of flowing into our network during these attacks. So it was really useful for us.
We also worked with our county office, so that they helped us with, working on our firewall and trying to help us mitigate some of that. So that was a good learning experience for us as well. I will say it doesn't help everything. I think this service is something that is needed for all K-12. Since we haven't had it, in the last week we've had four more attacks that we really couldn't do much about. We are looking at other services. They are quite expensive. We are not budgeted for it currently. So it's been a real challenge.
Yeah, but I'm sorry.
Okay, and to speak to both of the points, we did find in working with CENIC and working with our county and working with our internal resources that there's a lot we can do for specific types of attacks, TCP attacks, the SIM flood attacks specifically. We've worked really heavily on. And what was really awesome is right when this pilot ended, what we started getting hit with were UDP floods that ate up all of our bandwidth. And even though we are 10 gigs to our school site, we really don't see that happen very often. In the last week, twice we were taken down, 4 times we were hit, and twice we were taken down for an extended period of time. And there's nothing we can do on site or on prem that can have any impact on that. So as a district, one of the things we've been looking for are, one of the out of bounds scrubbing other services, and they're almost prohibitively expensive. And unfortunately, what we can do on site is limited. Our hands are kind of tied when they, eat up the entire pipe upstream from us. So
Yeah, I would say when I was at Colton, I too looked at commercial style scrubbers from a number of vendors, and it would have required a hardware investment and then an ongoing monthly retainer fee, upwards of multiple thousands of dollars retainer, not to do anything but be present, right, and do some traffic inspection. And then as if you were under attack and you implemented the mitigation services, your fees went up by triple. So you were looking at something, under attack at 10 gigs. You're looking at well over $10,000 a month, and maybe even closer to $20,000 a month, plus probably like a $25,000 or $30,000 capital expense just to buy the equipment necessary to get the commercial scrubbing in place. So, this is a huge impact on a district that didn't budget for DDoS mitigation, last fiscal year or 2 fiscal years. It's a lot of money to put aside, and for something you may or may not use or use intermittently, it's a hard value sell to your executive leadership. So, again, we were internally grateful for just allowing us to have the pilot and participate. And I think it does show a value add in the sense that I have colleagues in Riverside and San Bernardino County that have gone down the commercial route, and they're feeling that financial pain.
Right. And then we're going to go into some of the lessons learned from the CENIC side. Sana?
Right. So this is a long list, and the purpose of this list is to provide feedback on what kind of things to look at or to ask, or question to ask for anyone looking for a cloud-based DDoS solution. So this is a long list, and these slides will be available. So I'm just going to go through the ones that are what I thought were the most important ones. The first one I'll go over is the connectivity of the DDoS provider to the internet. So if they are a tier 1 ISP, this is a less of a concern. But if they're not a tier 1 ISP, what is the total capacity they have to their transit providers? Because at the end, they're going to be receiving all that bad traffic, and that could be a lot of traffic. So we want to make sure they have enough capacity, their transit providers. The other important question to ask is the capacity of the scrubbing center. So this is where the scrubbers, the devices, the tools they use to clean traffic, so they will receive all that bad traffic and they will be redirecting it to their scrubbing centers. So how much capacity do they have at their scrubbing centers? We looked at providers that had scrubbing capacity in this range, but at the same time, the question to ask is how many customers are served by that scrubbing capacity? The next one, really important, is the geographic distribution of their scrubbing centers. A lot of these attacks come from other locations outside the U.S. So the tools they use for their scrubbing solution, there's some well-known commercial vendors that have tools that prove themselves. So what kind of tools do they have? How good is the SOC? How good is the network operations center? Because this is a service that has to be implemented very quickly. Finally, this one is also important. In our solution, the CENIC NOC had access to a portal provided by the DDoS provider, but the DDoS provider did not have the capability of providing access to CENIC associates so they can have their own visibility into the portal. So this is something to look at as well, because all information from our associate about DDoS attacks would have had to go through the CENIC NOC, because only the CENIC NOC had access to the portal. The other ones I'd like to go over is how does the DDoS provider mitigate? Do they automatically mitigate, or do they provide some levels of control so that we can trigger mitigation ourselves? In our case, our option was to for CENIC to trigger the mitigation. We wanted to have control over the process of triggering mitigation. We didn't want to have the DDoS provider automatically go ahead and mitigate if they saw an attack. The next one is the IP space. Does a provider mitigate IPv4, IPv6, or is it only IPv4? The DDoS provider we went with, at least at that point in time, only provided IPv4 mitigation. What is the smallest scrubbable IP block that can be provided via the solution? Obviously, the cost and the cost of the solution. So how much IP space is provided via the solution? In our case, we had the provider give us a very good discount, so we were able to have a very large amount of IP space, but it wasn't enough to cover all associates. So what is the incremental cost of additional IP space? These are more bullet points that, the slides will be available if you have any questions. But the main reason here is just to get everyone to think about the questions to ask in the process of selecting a DDoS provider.
Right. And we're going to let Luis talk about some of the survey results. Luis did a survey with the participants, and we're going to go over some of those results really quickly and then open it up for Q&A.
Thank you, Philip. So first of all, I think we couldn't be happier with the results of the pilot, even though they were, in some cases, went through some excruciating pain to deal with these types of things. So we did do a survey. The feedback that we got from 26 of the participants was really good. I mean, overall, very satisfied with how the pilot was organized and how effective the mitigation pilot was. In some cases, folks, it really brought up that awareness of knowing that attacks were actually going on and they didn't know about them. We have the tools to do that. You can keep going, Philip. The next one. Really, their recovery times were definitely impacted. You could see 45 plus 18% were significantly or somewhat reduced in terms of their recovery time, and you could also see that their level of disruption was somewhat minimized in terms of getting them back ongoing. And this really resonates to the story with Poway, where they've been getting hit, and they were getting hit hard when we started initiating this pilot. And like Dustin said, they crashed the pilot in a very timely manner. And the feedback we're constantly getting is, and Dave articulated very well about cost and technical expertise, at least for K-12, is a significant barrier. We don't think we're equipped at this point in time in terms of budget to deal with these types of things. We're hoping that as we move forward, we can continue to work with CENIC to continue to have DDoS mitigation. Right now, we're at a stage where we're trying to secure state funding. We feel that we can make a case for the state to help provide funds for DDoS mitigation, some type of bolt-on to the CENIC backbone that could help our K-12 institutions. I think we could definitely demonstrate the economies of scale here. There's an issue around scale that is provided around doing this together. The pilot cost us around $100,000 for 5 gigs of service, and you can see benefit in 26 counties. I could tell you that some districts are probably paying that kind of amount just for their own.
And that one specifically is
just
one
for them,
yeah.
for a single institution. So, we hope we could come up with something. We understand that maybe other associates are interested in DDoS mitigation, so we'll continue this conversation with CENIC around how this could potentially continue in the future.
Great. And we don't have a lot of time, but I do want to see if there's any questions that would like to be posed to the group here. Right in the back there, or in the middle back, sorry, left. George. Oh, you need a mic? Anybody? Yeah, no, good question, right? So, as was stated at the beginning, the infrastructure itself wasn't something that was paid for directly with the pilot money. It was something that CENIC was in the process of building out for other things. So I'll give you a quick. I do have a quick picture of that. This is the infrastructure that CENIC built out for its own security monitoring efforts, and we piggybacked the K-12 DDoS activity into this. So that's going to stay in place because that's supporting our ongoing security event monitoring and management environment. So yeah, just the scaling part is adding to it if we're going to make this an actual service and being able to have the capacity to do that technically. This was the structure, so that's staying because it wasn't dedicated to the DOS part. We could, yes, very much so. Yes. Yes, that is a very good question. Yes, this. Okay, the question was this was showing stuff that was coming in from an internet source, and how would we possibly accomplish some kind of a mitigation for an internally sourced attack from within the CalREN network. I will very clearly state that was a scenario that the design would help identify. Luckily, we didn't really see that as an issue. But this particular solution wouldn't actually address that. So we would have to look at some other thing that might be able to help that. But the design of this wouldn't facilitate on-net attack sources being scrubbed. Good question. One more question. Well, the K-12 segment is definitely interested in going to production.
Incredibly. We are.
The question was, do we know what segments are interested in going into production? And K-12, I think, has already aired a couple times. They're very interested.
I would suggest that any segment that's dependent upon internet access would probably be interested in production.
I believe CENIC management, and I am aware that the UC environment has been negotiating some kind of a solution as well.
Yeah, and I think one thing, it's not all about having fat pipes. Some of these attacks can easily overwhelm things like firewalls and routers and other things, right?
Yeah. We do have 10 minutes. I just want to add something real quick about one of the things that I really liked about the pilot too was after mitigation, 48 hours, 24 hours after mitigation, Michael's team would provide a report, a PDF report basically about the mitigation and give us the details on it. It was really great. We could turn that over to the district. I think that's an excellent, it's a individualized kind of report for the districts to understand what services, the COE was providing vis-a-vis CENIC and K-12 HSN. It's really cool.
Right, yeah. Right. Yeah, and that whole attack size thing you were talking about, some of it felt like with the communication process, largest impacting events were in a smaller bandwidth area with these TCP SYN flood type things, where sometimes the attack was less than 100 megabit.
Yeah.
So size-wise, from a bandwidth perspective, not a lot, but very much felt by the target. Other questions? Right here.
At the core of this issue really is just funding, right? There's value that's been shown. There's considerable cost. So when we have these conversations, it's all about ROI, where money is coming from, and who it's impacting. So my question is in regards to, has there been any internal discussions or any work around drafting an actual business case to help quantify not only the operational but the instructional impacts to K-12 organizations by events like this? Because we all, really joke about this being down for an hour as an internet appreciation event. But the fact of the matter is productivity for most of our classified staff drops to zero. And our students in some cases are deeply impacted by lack of connectivity, whether that's broadly to the internet in general or specific services that have been taken down by these attacks. So has any work been done around that so that we could then roll that into reaching out to state level folks and even see a scenario where if there's a strong enough case that maybe that's a like great discussion. Is there any work in that arena?
Let me summarize real quick because I don't know if everybody else heard that thing. Just very quickly, is a business case been made for the K-12 community on why this should be moving forward? Go ahead, if you have something to say.
So that's a great question, loaded question too. This is something that we've been working on for over 4 years. This is not something we just, came up and said we want to do this. It's been a long time in the making. First step was to secure pilot, because I know, when I'm having to go out there to advocate for our K-12 folks in conversations at the Capitol in terms of funding, there's always, how can we demonstrate the data? So this pilot really will help us inform that decision. We are going to finalize a report with CENIC this month, and really to try to put it part of the 1920 budget package, and provide a proposal for the state to help us with DDoS mitigation, and at least for K. I can only speak for K-12. The more segments, we can get in, obviously, we can keep creating those economies of scale. But overall, I think that the pilot gives us a significant leverage in terms of building a case for doing DDoS mitigation.
I think to Terry's point, as San Bernardino County Superintendent of Schools, we operate under a JPA for providing those services to our customers, right? Our districts who are JPA members, our BestNet JPA. And if we were able to, if there was a cost recovery model, we could build that into our business plan and our annual fee increases or decreases, based on the additional protection provided.
And part of the challenge we have is we only have a certain piece of the puzzle. As you can see, one of my big takeaways of this pilot is that there is so much under the hood. I mean, the amount of work the CENIC engineers had to put on this stuff is not trivial. And so none of those costs were part of this pilot. CENIC had to, put upfront a lot of those resources in terms of time, engineering, and putting all these tools together. And so CENIC is at a point now where they have more information to really look at how this could be packaged for the charter associates, and look at some kind of cost recovery model that could benefit all of us. So all these things were to help inform that. Absent that, we're really swinging kind of up in the air, and so we hope to have some good solid numbers as we move along in the next future years. We can have something in place. I'm optimistic that we will have something in the 1920 budget. If all the stars align, we've got a lot of work to do here, and we only have a short period of time to make it happen.
Great. Anything else before we close out? Oh, we have one more hand right there.
The real quick question is the /24 the minimum size network that you need to route onto the service?
A /24 is, I think that's a standard for, go ahead, Sana.
So the standard is the minimum is a /24. However, our solution can mitigate as a /32 level. And the main reason for that is because our ISP provider is also our DDoS provider.
Right. So
and this is how we were able to get the most out of the 5 gig.
Right. The solution that we selected during the pilot, we were able to shorten that down to a 32-bit because of the architecture of that particular solution, which was very helpful. Let me give you a quick example. It reduced the 24-bit traffic of 2 gigabit of throughput clean return. When you target it down to a 32-bit, it brought it down into a couple hundred megabit of actual traffic of clean return that had to come through. So a huge difference being able to do that. Anything else? One in the back. So the solution that the question was any support of IPv6. The solution that we're working with didn't support IPv6. We understand that that is possible. Go ahead.
So to add to what Philip said, the DDoS provider we work with has IPv6 on their roadmap. So IPv6 is now a requirement for any solution we go forward with.
It would be.
Yeah.
Right. So we're going to have to, if we go into something, it will have IPv6, what particular vendor that is. Looks like we're out of time. Let's talk about that a little bit after the fact, because we don't really want to do salesy pitches or things like that right now, but we can talk directly. Thank you very much for coming and listening to us talk. And thank you, Luis, David, Dustin, Mike, Sana, Don. Thanks.